Hi guys, welcome to science. We are finally at the end of this unit, Unit 5, Weather and Weathering. And so this play posit is about all the things that we've talked about throughout this unit. And so I hope this can help you remember some of those things and help reteach it a little bit so that you can do well on the test. This first section is about clouds and how they're formed. Just a little review about that.
Hi, I'm Annie, the tiny water droplet. Some people may call me an ice crystal. My friends and I are found in the air, but we rose up into the sky with the warm air in the form of water vapor. As we climbed, we began to come together and formed all the clouds you are seeing in the sky. Together we can make up all kinds of clouds, such as cirrus, stratus, and cumulus. Plus we can even make special kinds of clouds like alto clouds and so much more. All these clouds look different and can tell you what kind of weather is coming or happening. I can't wait to tell you what kinds of clouds all my friends are making. Jerry, the tiny water droplet, and his billions of friends are currently making cirrus clouds. Cirrus clouds are the most common high clouds. Right now, Jerry is 18,000 feet from the ground. These clouds are one of my favorites because when Jerry and his friends are out, I can watch all the kids who are playing on the playground. Cirrus clouds bring nice weather and will travel from west to east. I hope you are enjoying this weather while you can, because in 24 hours, Jerry says there will be a change in weather. The next friend I want you to meet is Kimmy, the tiny water droplet. Kimmy and her billions of friends are making stratus clouds. Unlike Jerry, she is not way up high in the air, but is actually below 6,000 feet. This may seem high, but remember, Jerry, who was part of the cirrus cloud, was 18,000 feet above you. This is 3 times as high as Kimmy can be. Stratus clouds all look alike and are gray. Kimmy and her friends may look like fog, but she will not be touching the ground. Stratus clouds bring a light mist or a drizzle that can make for a rainy day full of puddle jumping and umbrellas. Make sure you wear your raincoat and rain boots when you see Kimmy up in the sky. Next, it's time for you to meet Leo and his friends. Leo helps make up cumulus clouds. Like Kimmy, who is part of the stratus cloud, he is below 6,000 feet in the air. Leo may not be very high in the air, but it doesn't stop him from making these fabulous white puffy cotton clouds. Cumulus clouds are flat on the bottom but look like cotton candy on top. Leo and his friends are surrounded by lots of blue sky and predict fair weather, but watch out if the cloud starts to grow tall. It can make a thunder cloud called cumulus nimbus. The wind will come in and flatten the cloud. The weather will go from fair to snow, rain, hail, lightning, or in some cases, tornadoes. Leo wants you to know that you need to always be prepared when you see cumulus nimbus clouds start to form. Cirrus, stratus, and cumulus are all the 3 basic types of clouds, but there are other clouds too, such as the alto clouds made by my friends Lacey and Artie and their billions of friends. Together, they make alto stratus and alto cumulus. Lacey loves being a part of the alto stratus clouds because unlike the other clouds that I have mentioned, they cover up the entire sky with what looks like a gray or blue-gray blanket of clouds. Alto stratus clouds let you know that rain or snow is coming. Artie, the water droplet, and his billions of friends make up the alto cumulus clouds. These clouds are gray and puffy. Artie and his billions of friends team up with other clouds in order to form groups. Alto cumulus clouds can make the cloud watcher know there is a chance of seeing some thunderstorms later in the day. Today, we have learned so much about different types of clouds. It was so much fun introducing you to all my friends. Remember, there are other types of clouds that I did not mention, but I hope you feel like you can go outside and name some of the clouds you see every day. Have fun cloud watching. Bye!
This next video is about weather instruments and how we use them to predict the weather.
And these instruments are also going to help meteorologists make a weather forecast that much more accurate. The first is kind of the obvious one. That's going to be your thermometer. Thermometers are going to measure the temperature outside, and out of your reference table, you're going to have 3 scales: Fahrenheit, Celsius, and Kelvin. Make sure you know how to convert from one to the other. Meteorologists also use barometers. Barometers are going to measure the amount of atmospheric pressure above us. Low atmospheric pressure gives us really rainy weather, a lot of precipitation. High atmospheric pressure is going to give us really nice weather, very dry weather. Atmospheric pressure in your reference table measured with two scales, millibars and inches of mercury. Make sure you know how to do those conversions as well. Anemometer. These are going to measure wind speed. Now those little cups spin around. The faster they spin around, faster the wind speed. Remember, you're going to have two scales. Sometimes you might see a station model with miles per hour with wind speed. Most likely, out of your reference table especially, you're going to see your wind speed in knots per hour. Meteorologists use weather vanes or wind vanes to determine wind direction. Now wind direction obviously is going to be north, south, east, and west. Just keep in mind, winds are named from the direction in which they come from. And finally, a rain gauge. Now rain gauges are going to be used to measure the amount of precipitation. There's a lot of different units that can be used here. Inches and centimeters are two of the more common ones that are going to be used. So meteorologists can use a rain gauge to determine the amount of precipitation from a storm.
This clip is going to be about weathering and erosion and what that can do to the rocks and the landforms around us.
This is Earth, home to 7 billion plus people, 7 continents, and all kinds of amazing plants and animals. This is what Earth has looked like for a long time, and will probably continue to look like for a long time, right? Yes, and no. Sure, this is what Earth looks like from space, but even though it looks pretty much the same from whenever we view it from afar, once you zoom in on it, you can see it's always changing. On a small scale, things like moving water shape the Earth's landforms, the natural features of the Earth's surface. On a bigger scale, the gradual shifting of the Earth's crust is slowly moving even bigger things like the oceans and the continents. So one day, our planet will look different, maybe a lot different from how it looks now. So how exactly does water shape Earth's landforms? Or to bring it back to the spheres we've been talking about, how does the hydrosphere affect the geosphere? To understand that, we need to discuss weathering. I'm not talking about the weather, like if it happens to be sunny or cold or foggy outside your window right now. I'm talking about weathering, the process that takes place as rocks and other parts of the geosphere are broken down into smaller pieces. Weathering can be caused by water, air, chemicals, plants, or even animals, including us. And there are 2 types of weathering you need to know about: mechanical weathering and chemical weathering. Mechanical weathering is the process of breaking big rocks into little ones. Frost, ice, the roots of plants, plants, running water, or heat from the sun can all cause mechanical weathering. Chemical weathering involves the changes that some substances can cause in the surface of the rock that make it change shape or color. Things like carbon dioxide, oxygen, and acids can all cause chemical weathering. And when rocks have been weathered and all broken down and are later moved by natural forces like wind, water, or ice, that's called erosion. Weathering and erosion sound pretty similar, right? Well, yeah. But not exactly. Think of weathering as the hammer that breaks down the rocks. Erosion is the process that carries those rock fragments away, or put in a way we're all familiar with. Weathering helps make a mess, and erosion helps clean it up. Let's take a trip to the beach to see what part the hydrosphere plays in weathering and erosion. This is a picture taken from space of the coastline of Massachusetts in the northeastern United States. It's part of a landform called Cape Cod, and the picture shows what the beaches and islands around it looked like in 1984. Now look at this photo from 2014. What's different? There are actually more islands in 2014 than there were before. Back in 1984, that long strip of land was North Beach. Now, that strip of land has been chopped up into separate islands. The top part is North Beach, the middle area broke off into North Beach Island, and the bottom part is now called South Beach. So, how did that happen? Well, moving water is a major cause of erosion, and there's a lot of moving water in the Atlantic Ocean. The intense energy of ocean waves crashing on shore causes pieces of the rocky, sandy coastline to break into smaller pieces or to weather over time. Then, natural forces like major storms and rising sea levels then move or erode these smaller pieces. Day to day, you might not notice any dramatic changes, but over the course of 30 years, well, as these pictures show, coastlines can change a lot. So what can we take away from this? Well, we saw that water can weather and erode Earth's landforms, and that's just one example. There are so many others, like floods weathering valleys or glaciers eroding mountains. Let me break it down for you this way. See what I did there? The hydrosphere shapes and sometimes moves the geosphere. One last joke before I sign off. What did the geosphere say to the hydrosphere? You crack me up.
This next section is about what we can do to stop things from eroding so quickly. Because we build on the sides of hills, or we build in places that can be eroded away, and that can hurt our homes or our buildings. And so we've come up with ways to prevent erosion from happening so quickly, and in this clip you'll find out how.
Hi, I'm Jared. Welcome to Fun Science Demos. The big idea today is erosion and how water has the power to shape our land. But we don't want the water to shape our land too much, because we need that soil to grow plants. We use those plants for food, and animals use those plants for food. So what you see in front of me are three different types of land. This first type is just bare soil. It's just soil. This next type has dead leaves on top, and the third type has plants growing in the soil. This may not look too exciting right now, but when it rains, that water has the power to change the land, and we're going to make it rain to see what that water is going to do to our land. So we cut the top off of 3 plastic bottles, and we put the same soil in each of those 3 bottles. All of these bottles have the same soil. We covered this soil with dead leaves, and we grew some plants in this bottle. We've also used other plastic bottles to catch the water that's going to come out of these when we pour it into the bottle. We want to pour water into each bottle and see what happens. Does that water have the power to change the land? What do you think is going to happen when we pour water into this bottle and it comes out into the cup? Will it be any different from the water we pour into this bottle as it comes into the cup? And will this one be any different when we pour water into this bottle and it comes out into this cup? So I'm going to slowly pour water in. You're going to see the water level rise, and we'll see what happens with our soil. We'll keep it coming. And now it's coming out. Take a look at the bottle we used to catch the water. Well, what do you notice? Well, it's cloudy. So why is it cloudy? That's because all the dirt and the soil from our bottle was washed into the cup. The water had the power to actually take the dirt and the soil with it out of the bottle and into the cup. The water moved the soil. It shaped the soil. So now I'm going to pour about the same amount of water into the next bottle. What do you think is going to happen? The water that we catch, will it be just as dirty? Will it be less dirty? Will we even be able to see a difference? Well, let's pour the water and find out. Here we go. So I'm pouring the water in. Making it rain. Adding water to our bottle. I can see the leaves floating to the top. Do we have any overflow? Yes, we do. Stop the rain and see what we have. So we've zoomed in so you can compare the two. This one has a lot of the soil in the container. This one just has a little bit of the particles, a little bit of the soil in that water. So why do you think this container is a little bit cleaner? Well, what's different between the two? Well, this one had leaves, dead leaves on top. And I think most of these dead leaves helped protect the soil underneath from moving with the water. So what do you think is going to happen with our third container? We have plants growing in the soil. What's going to happen when we add water and make it rain in this container? All right, here we go. Let's add the water. About the same amount. Pouring the water in. What do you think's going to happen here? Add a little bit more. It's coming out. We're going to stop pouring and see if we can compare what we see coming out. The water coming out of this container looks a whole lot cleaner than this one and a little bit cleaner than this one. So the question is why? Why is this water cleaner? I poured about the same amount of water into each container of soil. This one looks really clean. Well, to answer the question why, we have to zoom in and take a closer look at what's really going on here. So now we're all set to take a closer look at why the water coming out of this bottle was so clean and clear compared to the others. To do that, I'm going to actually lift these plants out of this bottle and let's see what happens. Well, what I notice right away is what comes along with all of the plants. Well, the soil is actually coming out too. When I flip it over, I think you'll be able to see why. So we've zoomed in so we can see what's going on here. Why is this soil staying together? Why is it staying in place? Well, you can see the roots from our plants grew into the soil, and almost like little fingers, those roots are holding the soil together. So when it rains, the roots keep the soil from washing away. The roots of the plant, that's what keeps the water from eroding the soil. Besides holding the soil together and in place, roots do another amazing thing. To show you that, I'm going to squeeze this and I want you to watch what happens. Where did all that water come from? Well, that came from when we made it rain on our soil. The roots of the plants helped hold that water in. Plant roots actually go deep into the soil, and this model is going to help us see how deep they can go. We're going to zoom in and see if we can see those really tiny plant roots that we have growing in our soil. We've zoomed in now so you can see these tiny roots in action. I'm going to point them out, and they actually extend from the plant all the way down to the bottom of our soil. I'll point out some of the bigger ones. They grow down into the soil. And think about what they're doing. They're holding that soil in place. All of these tiny roots getting nutrients from the soil, but they're also helping the soil out. Plants do an amazing job at keeping erosion from washing away too much soil. We need that soil. We depend on that soil to grow plants, and animals depend on that soil to grow plants.
I hope these clips helped remind you of some of the things we've talked about in this unit. And on Thursday, we'll be reviewing a little bit more and then taking our test. So for today, you can pass off Unit 5, Lesson 10, and watching the play pause, it counts as the exit ticket. So hope you guys have a great day. Thanks. Bye.